Okay, we are recording in this virtual office hours 4, chapter 6, and we've got several questions. We got 6.1, number 77/21. 6.1, 77/12. Let's see what this one is. Oops, sorry about that. That's not supposed to be there. There. And let's pull up our handy dandy. I'm not going to look at the directions. I'm just going to see what they give us, and then we go from there. Looks like f of x is equal to 2x plus 9 divided by x minus 5. And I know that I see the word inverse in there. So the first thing I'm going to do is rewrite this with y is equal to 2x plus 9 over x minus 5. And then I'm going to switch the y and the x's. This is what you do when you algebraically find the inverse. You switch the x and y's. So I'm going to make that a x equals 2y plus 9 over y minus 5. And now we're going to solve for y. So that means I'm going to have to get rid of this fraction first. So I'm going to multiply both sides by y minus 5. And now we've got x times y minus 5 equals, and of course you see the y minus 5's cancel, and that leaves 2y plus 9. And now it's just xy minus 5x equals 2y plus 9. And I got all the y's on one side, so I'm going to bring the 2y over and the 5x over. So it looks like we get xy minus 2y is equal to 5x plus 9. Factor out y, we get x minus 2. 5x plus 9, divide by x minus 2. And that last step, that y becomes a y to the negative 1 is equal to 5x plus 9 over x minus 2. And there is your y inverse of f of x. So let's see what they look like when you type them in the calculator, because that's the next thing I would ask. What do they look like? So y is equal to 2x plus 9, 2x plus 9 divided by x minus 5, x minus, parentheses, x minus 5. And then the inverse is 5x plus 9, 5x plus 9 divided by x minus 2. And of course, algebraically, you see that the function does not exist at positive 5 and positive 2. So you know that because you set the denominator equal to 0. So you know there's vertical asymptotes at 5 and 2. You also know that the x, 2 is your horizontal asymptote and 5 is your horizontal asymptote as far as horizontal asymptotes. So, and the graph. And I'm going to do a zoom 0. And that's okay. Let's do a zoom standard. That's better. And you see they're inverses of each other. How do you know they're inverses of each other? Well, xy is equal to yx. In other words, if they're inverses of each other, let's say we get a point right here. Let's pull a point from the first one. Let's go to second table. And let's go up to 1. Okay. Let's go to 1, sorry. 1 is equal to negative 2.75. So if we go to negative 2.75 on this one right here, negative 2.75, well, let me go the other direction, sorry. Negative 2.75 I'm not going to be able to see it. Anyway, a one-to-one function means the x and the y is equal to y to the x. And that's what gives you this mirror image of each other. See how they're mirror images of each other? Because the x for the pink is the y for the blue, and the y for the x is the x for the blue. And it's vice versa. So that's how you get the mirror image of it. Okay, so what I want you to be able to do with these, I want you to be able to find, algebraically be able to find y to the negative 1 or y inverse. And of course, find the vertical asymptote, horizontal asymptote, since 2 over 1, since x is the first power, they're the same, be 2 over 1. And here would be 5 over 1. Okay? Those are the kind of things I want you to be able to do with inverse functions. All right. And you see that's what they're asking you. Domain, all real numbers except for negative 5 on the function, and all real numbers except for 2 on the function, on the inverse function. It's a good little test question. I like that one. Next question. That's 6.1. 6.2 is next. So 6.2, 25/7. 6.2, 25/7. Let's see what this one looks like. Okay, basically horizontal shift because the x is, so we know that you got to go to your parent graphs. F of x is equal to 3 to the x minus 4. And we know that y is equal to 2 to the x, crosses at 1 right there. So you know that this function right here follows that same 3 is not far from 2, so I'm really not worried about the 3. But the negative 4 means 4 places to the right, horizontal shift. So this is our, so 1, 2, 3, 4. So 4. And now it looks like that. And of course, you can check that on your calculator, but the horizontal shift is 4 to the right. Horizontal shift equals 4 to the right. And domain is all real numbers because you don't have a fraction and you don't have a radical. And the range is from 0 to infinity. Range is equal to 0 to infinity. And you don't touch 0, and this is equal to the domain. And that's all I would ask you on a test. Good test question. There you go. All real numbers and 0 to infinity. The equation for the asymptote, I don't understand what that is because got the equation right there. I don't understand the equation for the asymptote. You had a vertical asymptote, looks like 6. But I don't know what they want there. A line, a vertical asymptote. I don't understand. Y is equal to 0. That's the x-axis. We said that with the range, 0 to infinity. The function is increasing on its domain. Put your car right here, and that's what I tell students. Whenever you want to know increasing or decreasing, which way do we read? Left to right, put your little car right there, and tell me what that car is doing from left to right. It's what? It's increasing. So this one's increasing. I don't understand that y is equal to 0. They've already asked the range. Why would they ask that? It matches with the range. The range is from 0 to infinity. So the asymptote, why didn't they say where is the horizontal asymptote? If they said where is the horizontal asymptote, then I would have said y is equal to 0. That's a good question, but I don't agree with this right here. I think it should say the equation of the horizontal asymptote is. Anyway, pretty good question, except for that part right there. 6.275. 6.275 / 20. Okay, this is a good test question, but it's basically 6 test questions or 7 test questions. I wouldn't give it to you as one, but each one of these is a test question. And all you got to remember is A is equal P 1 plus R over N raised to the NT power. And P is what you put in. So you put in $5,000, P is equal to 5,000. R is equal to the rate, and it's given as a percent, but you change it into a decimal. N is equal to the number of times compounded, and that would be like yearly or annually. If you see the word annually, is that spelled right? N is equal to 1. Semi-annually, N is equal to 2. Quarterly, N is equal to 4. And monthly, N is equal to 12. They do have a daily, but daily is not used that much. That'd be 365. And T is how long you're going to leave the money in the bank in years. How long you're going to leave the money in the bank in years. So if you leave it for 6 months, that's equal to 0.5. It's always got to be in years. Okay? And now you just plug and chug. I'm not going to do all of these because it's just calculator work. So here, let me write down the information. So 1,000, P is equal to 1,000. Let's see what else. Okay, 3%. So R is equal to 3%, which is equal to 0.03. Compounded, they got the compounded, let's see, years. Okay, compounded annually or monthly. Let Y1 represent the value of compounded monthly. Wait a minute. Okay, let Y1 represent compounded annually. Let Y2, okay, Y1, I don't know why they do stuff like this, is equal to annually, so N is equal to 1, no monthly. Y1 compounded annually, N is equal to 1. Y2, N is equal to 12. They just about screwed up a really decent question. Okay, I'm going to show you how to calculate this. I'm going to do it for the first two, but it is a little bit ridiculous of a question. Anyway, A is equal to P times 1 plus R over N raised to the NT power. And I'm going to do it for Y sub 1, where N is equal to 1, and Y sub 2, N is equal to 12. So A equals P 1 plus R over N raised to the NT power. So A is equal to 1,000, 1 plus 0.03 over 1 raised to the 1 and times first year, the 1 right there, the year. Here, A is equal to 1,000, 1 plus 0.03 over 12 raised to the 12 times 1. And now you just do all this on the calculator. Let me show you how to do it. You work your way on the inside out. So I'm going to pull this, well, I can't. So 0.03 divided by 1 plus 1. 0.03, hold on a second. .03 divided by 1 plus 1, and we're going to raise that to the 1 power and multiply by 1,000. So after 1 year, A is equal to $1,030. So you made 30 bucks in 1 year, compounded yearly. Now let's go back and do we did 1,030 at 1 year. Now let's do compounded monthly for 1 year. So that's going to be clear. So 0.03 divided by 12 plus 1 raised, and 12 times 1 is 12, and then multiply that by 1,000. And you made 42 more cents with Plan B. So you can see there's not much difference between compounded yearly and compounded monthly. It gives you an extra 42 cents. And you do that for each one, and that's what I will test you on. I will test you on this right here. Now, they want you to graph this and graph this, and they want you to graph it. I guess it says graph it, or it says you are given the choice of investing. Then use a table to compare the graphs numerically, which is the difference between blah, 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 blah. It looks like to me you're going to have to calculate each one. So let's do 2 years, or let's do 10 years. Let's do 10 years. So here we go with 10 years. This is t equal 1 year, t equals 1 year, t equals 10 years, t equals 10 years. So A is equal to 1,000, 1 plus 0.03 divided by 1 raised to the 1 times 10 years. And over here, A is equal to 1,000, 1 plus 0.03 divided by 12 raised to the 12 times 10, because t is equal to 10. You're going to multiply it by n. So let's go ahead and run this through the calculator and clear. And that's going to be 0.03 divided by 1 plus 1 raised to the 10th power multiplied by 1,000. So after 10 years, compounded yearly, you're going to get $1,343.92. Now let's do it compounded monthly. So that's going to be 0.03 divided by 12 plus 1 raised to the 120th power multiplied by 1,000. And that's going to give you 1349.35. So after 10 years, you've got a difference of $6.63. I don't know, 62 cents, something like that. Not much difference. And I did it at t is equal to 1 year and t is equal to 10 years. Just plug and chug and work it on the calculator. That's all I want you to be able to do. And let's go with the last question on 6.2. That's 77. 6.277/21. Okay, this one you want to do on the spreadsheet or the calculator. I'll show you how to do it on the spreadsheet and the calculator. So how do you do it on the spreadsheet? Well, pull up the Excel spreadsheet and punch those numbers in. Now you might have to rewind this on the tape measure, on the video. All right, put your numbers in: 0, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, and 10,000. And now let's put our other numbers: 1013, 886, 774, 677, 592, 517, 452, 395, 345, 302, and 264. And highlight those two. excuse me, and go to Insert and go over to Charts and Scatter Plot. And there is your scatter plot of those points. Now, what is the best fit line for those points? Well, I'm going to show you. Right click, go down to Add Trend Line, and you pick the best fit. Now, there's linear. That's okay. Exponential, that's a whole lot closer. I like exponential. Logarithmic, nope. Can't do logarithmic. Polynomial, ooh, that's close. Let's check between polynomial and exponential. I would say polynomial is a little bit closer. Power, nope, can't do power. So let me go back. Sorry. So it's either polynomial or exponential. I think polynomial is the best one. And go down, scroll down and hit display and display. And there should be your two things of information. You got your y is equal. You got your R coefficient, which you don't even know what that means, but that's called a correlation coefficient, which means the closer it is to -1 or +1, the more correlation you have or best fit. And that's 6 zeros. So that's going to be 0.00, I'm sorry, 0.0, yeah, 5 zeros, 0.000004 x squared minus 0.1059 plus 959.01. I think that one's pretty close. That's polynomial, but let's see. You know they got the pictures right here. Let's see. Exponential. Okay, they want exponential, so we'll go with the exponential since we're in the exponential section. We'll go back to the spreadsheet and change it to exponential. Add trend line, exponential. They want that one. And display. There is your exponential. And as you can see, they're real close. So that's going to be 978.14 e to the negative 0.0001. And let's go to your calculator, excuse me, and punch these in. So let's go to your calculator and punch them in. And we're going to go to Stat, Edit, and there's your spreadsheet. Just type them in. 0, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, and 10,000. And then plug in your Y's, 1013, 886, 774, 677, 592, 517, 452, 395, 345, 302, and 264. And now I'll go to Stat, Calculate, and since we know it's exponential, we'll go down and do exponential. And make sure the first one says L1 and the second one says L2. You can change that by hitting second and go above the 1, 2, 3, and 4. You go up to L6, yeah, and hit calculate. And there is your information. Y is equal to 1013.31 raised, I'm sorry, 1.03 times 0.99999 raised to the x power. Excuse me. And there's that question. Now, if you want to graph it, you can go to Stat or Second, Y is equal. Turn on your plot, and it's already defaulted to scatter plot, L1, L2. All that's default, but hit graph. And you need to go through and take out these two, clear and clear. Now hit graph. And let's go to second zoom and go down till you see the word stat, which is 9. All right, there's your plot of your points. Now I'm going to go through, excuse me. Oh, for some reason I'm yawning. I'm going to go through and type in what we got for linear regression. So I'm going to go to Stat, Calculate, and go down to Exponential and Calculate. And mine is going to be Y is equal to 1013.313879 times 0.9998654,613, all that raised to the x power, and it should fit. So Y is equal to 1013.313879 times 0.999865613, and put parentheses around both of those. Second insert parentheses, and all that raised to the x power. So raised to the x power. Well, raised to the x power. And that should fit in here, but it's not. I don't know why. Let's take 1,000. Let's multiply that. Oh no, did I just hit clear? Sorry about that. Second quit. Let's go with 1013.3138 times 0.9998654,613. And that's 1013, so 0.177. 1013.177. 1013.177 raised to the x power. And for some reason, it's just not graphing. I don't know why. Zoom, standard, or stat. Zoom, 0. Yeah, I'm not getting it to graph for some reason. Zoom, O, or let's see, standard is 6. I don't think that's right. I'll have to look at this one again because it's not. They're only asking you to graph it, but in 1500, I don't understand why it's not. Well, there it is right there. That's what we've been getting. Oh, I'm putting it in the wrong place. My bad. You know, we're getting it in the right place. I didn't put that other part in there. Let me go back and see. I apologize. Stat, calculate. I'm going to call it exponential. L1 and L2, calculate. That 0.99865 is supposed to be up there with the x. So that's where I messed up. My bad. All right, let's look at the last question. Last question says 6.511. Okay, this one, solve equations, and probably the best way to solve this one is to take the log of both sides. You could do that. Combine that 3 and that 6. Yeah, let's do, they got a natural log right there, so I think they took the natural log of both sides. Again, this is 6.5. 6.5/1/1. And it is, and this is a test question. Any questions solving equations with natural logs? That's going to be a test question. I'll tell you that right now. 4e to the 3x plus 3 is equal to 6. Well, there's too much here, so you got to get rid of that 3. So 4e to the 3x is equal to 6 minus 3. So 4e to the 3x is equal to 3. Now at this point you can do different things, but I would go with the natural log because anytime you're dealing with e and you're solving an equation, it might help you to take the natural log of both sides. You could divide by 4, and that would be e to the 3x is equal to 3/4. That'd help you out. Take the log of both sides, and log cancels the e out, and you're left with 3x. Natural log cancels the e, so you're left with 3x is equal to the natural log of 3/4. Divide both sides by 3, and x is equal to the natural log of 3/4 divided by 3. Do that in your calculator. So if you did that in your calculator, and that's what they got, 1/3. I just got the 3 on the bottom. See this right here? You could put the 1/3 out front, or x is equal to 1/3 natural log of 3/4. You could do it like that. That's your answer. That's a good test question. Anytime you have a natural log or an e or a natural log, solve an equation, that's going to be on the test. Okay. And that is the questions for today. Well, for 110, that is. And I'll stop the recording and send it over to y'all.